spring force. Yeah, spring force. We have discussed a little about the spring force we have seen. Now here in the work done calculation, again the spring force will come. Newton's laws also we have seen about the springs. Next, let's see this one, spring force here. Look at now. Spring force, whenever there is a compression or elongation, then only we have a spring force is developed. The spring force, and which is directly proportional to what tell me now? Minus x, where x is called as a elongation or compression. And the spring force is always opposite to the elongation. That's why minus sign. Now we can use one proportionality constant, the proportionality constant which is a k, where k is called as a spring constant, where k is called as the spring constant. The force, the spring force is given by what, tell me now? Minus kx. Spring force is minus kx. And when there is an elongation or compression, then only spring force is developed. And the spring force, when you apply the external force like this, and the spring force is opposite to the external force. And when you compress the force like this, then spring force is like this. Okay, that's why we have a negative sign. Next, work done by the spring force. The work done by the spring force, which is equal to W, which is equal to minus 1 by 2 kx square. Work done by the spring force, which is equal to minus 1 by 2 kx square, where k is the spring constant and x is the elongation or compression. And work done by the spring force is negative. Why? Because displacement and force are both are in a opposite direction. That's why we have a negative will come. Force and displacements are in opposite direction. Now let us consider initially the spring has a elongation. We have x1. I want to change from x1 to x2. Initial elongation is x1. Final elongation is x2. Then the work done, which will be given as, which is equal to, that is 1 by 2 k x1 square minus 1 by 2 k x2 square, where x1 is the initial elongation, x2 is the final elongation. 1 by 2 k x1 square minus 1 by 2 k x2 square, where x1, x2 are the initial and final elongations. The work done by the spring force depends upon what, tell me now? Only on initial and final positions only. It depends upon only on initial and final positions only. Right. Next. And the spring will have a energy. Spring, yeah, that energy is called as the potential energy. The energy stored by the spring, that energy is called as a potential energy, which we can also call it as the elastic potential energy. So the potential energy of the spring, the potential energy of the spring will denote with a letter of U, capital U, and which is equal to 1 by 2 kx square. The energy stored by the spring is what, tell me now? 1 by 2 kx square, where k is the spring constant, x is the elongation, U, capital U. Potential energy symbol. Symbolic representation of potential energy will denote with a symbol of U. U is a potential energy. And this is also called as elastic potential energy. So this potential energy or elastic potential energy, which is given as what, tell me, we can say 1 by 2 kx square. That is also equal to, we can write, we have a F is equal to minus kx formula is there now. Yes, from that we can change to this formula, which is equal to 1 by 2 k into x is equal to F. That means it will come F into x. And that is also equal to what we can say now, this is F square by 2k. F square by 2k. So we can find the F value here. If I put this one, we can get x is equal to F by k na, will come like this.